everyone. So today we are discussing topic is impedance matching. What is the impedance matching? Impedance matching is nothing but source, once entering is the source side and receiving side the load side. So whatever the source side voltage and receiving voltage must be equal. We maintain to the source impedance and load impedance must be equal. That is nothing but source impedance. ZS is equal to ZL must be equal. So that is nothing but impedance matching. To adjust the source impedance and load impedance, that is to adjust the source impedance and load impedance, that is nothing but the simple thing, impedance matching. So here nothing but we can write as input impedance is equal to output impedance. So what happened? If it in case of to maintain to the impedance matching, nothing but source and load both are impedance must be same. What happened? So at the condition, first of all, to reduce the reflection, whatever the reflections will be there in the electronics sides and communication sides, so the reflections must be reduced. And similarly, maximum amount of power will be transferred. The maximum amount of power will be transferred to the primary side to load, source side to load side. So maximum amount of power will be transferred. So due to again some advantages nothing but when the maximum amount of power will be transferred, the device will be operating as a high speed and high frequency. When the device is operating as a high speed and high frequency, that is more advantageous. So whereas from the case of impedance matching is what is impedance matching? Load and source, both the impedance must be adjusted equal. So what happens if it is the both the impedance is adjusted equal? What happens? To reduce the reflections and same case maximum amount of power will be transferred. So that the case of what happened, it will be operating the advantage for the high speed operation and high frequency devices. So again some case of impedance, when the impedance is matching, so total power dissipated on the resistance only. Total power is dissipated on the resistance only. So what about the, for example, we are taken to the AC circuit devices. So AC circuit device, the two powers will be actually three powers. So one is the active power, reactive power, apparent power. So what about the reactive power? Reactive power is nothing but it is a type of losses. So we are case now, we are producing, the power is dissipated only resistance. So only resistance. If it in case of, we can consume active power, reactive power, apparent power. When the apparent power will be increased, so maximum amount of power will be losses. The apparent power is increased, maximum amount of power will be losses. Here apparent power is nothing but apparent power is equal to active power square plus reactive power square. So if it in case of we reduce the reactive power, automatically we reduce the apparent power. When the power will be reduced, automatically maximum. So what happens when the power will be reduced? So when the power will be reduced, automatically maximum amount of power to transmit to the source to load side. So which power? Reactive power. Reactive power is consumed on the line. So line is consisting of resistive, reactive component, capacitive components. So when the resistive component power and reactive capacitive component power will be reduced, nothing but this will be reduced, automatically maximum amount of power will be transferred. So what happened? Whatever the losses will be reduced to reduce the losses. So in the case of when the impedance will be matching, only the power is dissipated on the resistance, whatever the remaining things, nothing but XL is equal to XC, both are to be maintained. This maintained constant is nothing but resonance condition. So when the resonance condition, what happened? The maximum energy stored in the inductor and capacitor. So maximum power is dissipated. Power dissipated in the resistance. Whatever the two inductor and capacitor, these two are power does not dissipated. These two are power is reflected back. These two power are reflected back. When the two inductor and capacitors are power is reflected back, automatically inductor is the power is reflected back and stores to the capacitor, and capacitor is reflected back, the power is stores to the inductors. So those two are maximum energy stored. So maximum energy stored. What is the formula for maximum energy stored? XL into maximum energy stored formula E is equal to of Li square, and capacitor's maximum energy stored formula E is equal to of Cv square. Okay, they are the maximum energy stored in US. So what is the overall concept? So when impedance is matching, when the impedance matching, the total power is dissipated on the resistance only. Total power is dissipated on the resistance only, and react inductor and capacitors both are the power is reflected back. So reflected back is nothing but inductor and capacitor both are maximum energy stored. So the energy is not, the power is reflected. For example, inductor the power is reflected back and stores to the capacitor, and capacitor is reflected back and stores to the inductor. So these two are interchanging the power. So whatever the remaining active power is dissipated on the resistance only. Okay, so in the case of, we can find out the, from the circuit we can find out the whatever the resistance value, what is the resistance, and similarly what is the, when only power is dissipated on the resistance only, so we can find out the quality factor also. What is the quality factor? So from the case of, we can find out the quality factor, we can find out. When the quality factor is nothing but, what is the quality factor? Maximum energy dissipated on the devices by, maximum energy stored by and maximum energy dissipated. So that is nothing but the quality factor. So we discuss the only the simple equation. I think understanding the concept. So okay, we can draw the circuit here. We are consisting of three elements, that is R, L, C. Only power is dissipated in the resistance. These two powers are, power is does not dissipated, the power is reflected back. Power is reflected back. So these two R is connected, resistance and inductor. Resistor and inductor, R and L. So they are connected on capacitor. First we can find out the impedance. Simply we can find out the impedance. So when the impedance, these two are series in capacitors in parallel. So these two are in parallel. So there is the impedance formula R plus J omega L. In parallel with the capacitor, the capacitor impedance is J omega C. I think what is the omega L? Omega C. I think we know, if in case of, what is omega L? XL is equal to 2 pi FL. XL is equal to 2 pi FL. So 2 pi F is nothing but omega. So XL is equal to omega L. Similarly, XC is equal to 1 by 2 pi FC. So these are omega. So XC is equal to 1 by omega C. From the case of XL and XC, so we write it. So both are in parallel. So what is the formula for parallel condition? What is the formula for parallel condition? The parallel is nothing but R1 in parallel of R2. So what is the formula? R1 into R2 by R1 plus R2. Similarly, we can write that the R1 consisting of this part is R1, this part is R2. So we can write as Z is equal to R1 into R2, R plus J omega L into 1 by J omega C by R1 plus R2, R plus J omega L plus 1 by J omega C. We can simplify this equation. So Z is equal to R plus J omega L by, so this is the R into J omega C, J omega L into J omega C plus 1. Okay, so they are the impedance formula. So it will be converted into admittance. So what is the admittance? Admittance is equal to 1 by Z. So let us so it is transferred to, changed to the impedance format. So impedance is changed to the admittance format. So in admittance is equal to 1 by Z, nothing but its reverse, R plus J omega L, J omega C plus 1 by R plus J omega L, R plus J omega L. So we can write as, again, simplification only, just only simplification. What we do? Only simplification. So in this case, so we divide these two are dividing parts, so we can cancel these two are cancelled, so we can write as j omega c plus, so 1 by r plus j omega, what is this, l, dual confused, l and c. So y is equal to impedance is equal to right. So from the case we can observe what we find out, we can find out the resistance value, and similarly from the resistance value we can find resistance value, at the same case we can find out the quality factor formula. Okay, from the case we are find out the resistance, we can observe, so these are the imaginary, so these are the imaginary, these are the real part. So to divide the imaginary parts and real parts, so that the case of we are using some complex equation, we are taken to the some complex equation. So y is equal to j omega c plus 1 by r j omega l. We added to the complex equation, so here we can write as r minus j omega l, r minus j omega l. So r minus j omega l, both are cancelled. The equation is does not effective. So again we can simplify. Y is equal to j omega c plus r j omega l. We can write as r square plus j square is a minus of minus plus. We can write as omega. So both are omega L square. So from the case of we can divide the imaginary and real parts. We can divide in the imaginary parts and real parts. So what are the here we can write as real part is equal to r j omega c plus r square plus omega L whole square minus j omega L r square plus omega L whole square. From the case of divide imaginary and real part. So first we can write the real part. What is the real part? So y is equal to real part. First we can write the real part. What is the real part here? R by r plus omega L whole square. What is the imaginary? Imaginary part is equal to, we can write as both the case of j is common. So omega c minus omega L by r square plus omega L whole square. So we are dividing the imaginary parts and real parts. So these are the real part. Y admittance. What is the real part? Y admittance real part is equal to r by r square plus omega L whole square. From resonance condition, so here we can find that from the resonance condition. So resonance condition is nothing but resonance condition is equal to XL is equal to XC. From the case of we can find out the resonance frequency omega naught is equal to 1 by root LC. So these are the equation 1. From the resonance condition XL is equal to XC. From the case of resonance condition omega naught is equal to 1 by root LC. So we can find out the resistance value, it is a real part is equal to r by 1 by r square plus 1 omega L whole square. So in this case omega is equal to omega naught. We replace with omega in place of omega naught. So I can have it. Omega is equal to omega naught. So it will be substitute on y admittance in real part in admittance. So r by r square plus omega naught L square. So what is case of omega naught? Omega naught is equal to under root of LC square. Omega naught is equal to under root of LC square. So we can write as from the case of we can write as admittance formula. They are the completely admittance formula. So again we are divided into we have shifted to R admittance is equal to R resistance is equal to 1 by admittance. So from the case of R square plus omega naught L square by R, again we can find out the real part. R is equal to R cancel, R plus omega naught L whole square by R, omega naught L square by R. So we can substitute, we can calculate the remaining equation. Wait a second. Okay. So here R dash is equal to 1 by y, R dash is equal to R square into omega naught L whole square by R. So from R dash we can find out the R dash. R dash is equal to, we can common the R. When it is a common the R, so these are common the R 1. So by omega naught square L square, by in this case we can common the R, we can write also R square. R square. So R dash is equal to, we can write as whatever the R dash impedance matching, R dash is equal to R 1 plus, so this is nothing but omega naught L by R. So for example R and L both are in connecting series, so these are the quality factor is equal to omega naught L by R. So here we can write a simple thing, these are the quality factor formula. So these are the complete, the remaining, these are the real imaginary part. Imagine L part is given, L is a reactive component. So these are completely we are taken as quality factor Q square. So what is the Q square? What is the Q square? Q square is equal to omega naught square into L square by R square. So we can add as Q is equal to omega naught L by R. So this factor is the quality factor formula. So what is the power is dissipated on? Power is dissipated on the only resistance. What is the resistance formula? I dash is equal to R into 1 plus Q square. So Q square is nothing but omega L square by R. So these are the concept for impedance matching. What is the purpose of impedance matching? So what is the purpose of impedance matching? What is the purpose of impedance? So maximum power is transferred. Maximum power transfer and maximum power transfer and high speed high frequency devices. So okay, that is the maximum power transfer concept. Thank you.